let's look at the graphs of trig ratios. So graphing. Okay, let's start with sine. Let's say sine x. Now what we are going to do is we are going to look at a few properties and few expressions. We need to understand what is the domain of sine. Domain means what are the values of x that we can provide, and then the range. Range means y value, corresponding y value for a given x. Then we are going to look at how 2x looks like, how 3x looks like. We will see how minus x looks like. Then we will look at sine square x, sine cube x. Yes, and this pattern will follow for all the functions. Now let's type in the function sine x. If you notice, at x equal to 0, sine of x is y. Here the coordinates is 0, 0. So which means both x and y are 0. Now as we go towards the positive direction, it starts moving from 0. Remember, 0 by 4, 1 by 4, 2 by 4, 3 by 4, 4 by 4, 3 by 4, 2 by 4, 1 by 4, 0 by 4. Then it goes into negative. Minus 1 by 4, minus 2 by 4, minus 3 by 4, minus 4 by 4, minus 3 by 4, minus 2 by 4, minus 1 by 4, 0. And then the whole cycle repeats. Okay. Now, if you compare the graph on the positive x side with the negative x side, you will notice that the whole thing is reversed. Here it is increasing in the beginning and then decreasing, whereas in the negative x direction it is decreasing first and then increasing. So what does that mean? If you come here, let's say 1 by 4, 2 by 4, 3 by 4. Here it is what? Minus 1 by 4, minus 2 by 4, minus 3 by 4, minus 4 by 4. Right? So what this means is sine of minus x is nothing but minus sine x. Let's see. Okay, then second thing is, if we zoom out, it seems to keep repeating, right? So as we keep zooming out, it may look like a straight line, but it is actually not. Then let's say y is equal to 1, right? That is the upper range of the y values. Y is equal to minus 1, that is the lower range. Okay, x is equal to 2 pi. Yes, let's zoom out a little bit. 0 to 2 pi is one complete cycle. Y is equal to, no, x is equal to minus 2 pi. Remember, this is y is equal to 1, y is equal to minus 1. This is 2 pi, this is 2 pi. So from 0 to 360 degree. What is the domain? What is the domain? Domain of sine x, there is a possible x values that we can provide, is all real numbers. Okay, so we can say x belongs to real numbers. Yes, we write it as, if you notice, y values will be in between 1 and minus 1. So start with the lower range. Minus 1, 1. Minus 1 is less than or equal to y, which is in turn less than or equal to 1. Or we can also write minus 1 is less than or equal to sine x, which is less than or equal to 1. In other words, we can read it as sine x is between minus 1 and 1, including minus 1 and 1. Now you should be able to visualize how 2x will look like. Yes. Let's zoom in. Let's see sine 2x. Yes. Sine 2x. The whole thing looks more scrunched up, right? More number of waves within a given range of x values. Okay, sine of 3x, much more scrunched up. Now since it looks very confusing, let's say plus 2, right? And let's say minus 2. Yes, now what has happened is the whole thing has shifted up and down. This is plus 2, this is minus 2. Okay, now what about sine minus x? Sine minus x. You notice the whole thing is reversed, right? So where it is plus, it has become minus. Plus, minus, plus, minus, plus, minus. So we can say sine of minus x is equal to minus sine x. If you look at the identities in the previous sessions we have looked at, it is exactly sine of minus x equal to minus sine x. Okay, how would sine square x look like? Sine square x look like? Now, first of all, the moment you square it, well, let's plus 4 it so that it goes up, right? So the whole thing looks confusing. Let's remove this. Let's remove this. We have seen what happens. Okay. Let's remove this plus 4 from here. Let's remove this also. Now this is sine square x. Now what's happening here? First of all, there will not be any negative values. So in case of sine square x, what happens? Range becomes 0 to 1. Because of square, then the minus negative sign disappears. So it will be between this. Otherwise, there is no change. What about sine cube x? Sine cube x. Yes. Now because of this cube, the graph will be different. Look at this. Right, and I try to put some values for x and then calculate the cube of it and see how it changes. Now, so let's look at cos now. Now that we have got a feel of what we are looking at, let's look at cos x. Yes, sin x, sin 0 was 0, cos 0 is 1. And if you keep zooming out, it will keep going on and on in both negative and positive direction. So which means that the domain is that is x value all real numbers. Yes, belongs to x belongs to real numbers. Now what about the range? Yes, this remains in the same region, that is -1 to 1. So -1 and 1. Y is between -1 and 1. Or in other words, cos x. Okay, now let's look at cos 2x, cos 3x, right? Cos minus x, cos square x, and cos cube x, and also cos of minus x we need to see. Let's see cos, it's all scrunched up, cos 3x. Again, what we can do is to make it move up and down, plus 2 and minus 2. Cos square x. Yes, just like with respect to sin square x, no negative values. Okay, let's remove this. And let's see cos of minus x. See, it's exactly the same. So cos minus x is equal to cos x. Now let's look at tan x. Let's draw the graph. Let's remove this first. Tan of x. Wow. Yes, now here what is happening is, you have the curve, one of the curves going from minus infinity to 0 to plus infinity. Yes, and let me say y is equal to x is equal to pi by 2. Yes, just wanted to draw the line. X is equal to minus pi by 2. Okay, now let's understand what's happening here. Now for tan x, domain would be what? See, if you notice on this line, the tan x graph is not appearing at all. It doesn't seem to be touching this line at all anywhere. You can zoom in and move in around anywhere. If you keep going down, it may look as if it is going to touch it, right? It looks like now it is exactly on top of that line. But if you zoom in, as it becomes 44, instead of 44, 44.5, 44, we go into, right, the gap increases, right? So basically this line which tan x doesn't seem to be touching is called an asymptote. Okay, and that is one value of x is that can't be included. So let's see what I mean? First of all, x belongs to all real numbers. Okay, that is there, but there are certain values in these real numbers that can't be included in the domain. Now, what are they? So let's understand this. We know tan x is equal to sin x by cos x. We know denominator cannot be equal to 0. Yes, that means cos x cannot be 0. Now, when is cos x 0? When x is equal to, remember, cos 0 is 1. So, pi by 2, that is 90 degree, it is 0. Then 270 degree. Now 270 degree is 3 pi by 2. Remember, here we have shown this, what 1.6 is. It should be actually, I think I moved it, pi by 2. Right? Similarly, x is equal to 3 pi by 2. Yes. And this keeps going, right? 3 pi by 2, 5 pi by 2, 7 pi by 2, and goes on. And also in the negative direction, minus pi by 2, minus 3 pi by 2, minus 5 pi by 2, minus 7 pi by 2. Okay. Yes. Normally how we write is we put minus pi by 2 and put dot 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 in the other direction. Anyhow, so x, when this is equal to these values, then cos x equal to 0. So that means it can't be, x can't be equal to these values. So we say domain is x belongs to R and x is not equal to, yes, now remember these are all odd multiples of pi by 2. 3, 5, 7, these are all odd numbers. So the general expression for odd numbers is 2n plus 1. Yes, 2n plus 1 pi by 2. Yes, where n belongs to integers. Remember, it can be both negative or positive numbers. So that's the domain. So if you are asked what is the domain of tan x, you have to write x belongs to R and x is not equal to 2n plus 1 pi by 2, where n belongs to integers. Now, quite a big thing. Okay, what about the range? Right? The range would be, if you notice, look at the graph itself. It goes from minus infinity is less than or equal to what? Y or tan x, which is in turn less than or equal to infinity. So it goes from minus infinity to infinity. Okay. Now what happens if I add a number to it? Say tan x plus 2, right? The whole thing shifts up, that's all. So in other words, your y-intercept goes up, right? So the graph itself moves up in a way. Just confirm it, plus 3, see it's going up. Okay. So just like in this one, in the previous sine and cos, so let's look at tan 2x, tan 3x, tan minus x, and then okay, let's look at tan 2x. Yes, it has become a little bit straighter, right? Now let's make it 3x, much more straighter. Now all the negative values have become positive values, right? So all the negative values have become positive values. So accordingly your range will change. Remember, for tan x it is minus infinity to infinity. Now when we square it, it becomes plus infinity to plus infinity, right? Within each specific domain, right? So minus pi by 2 to pi by 2, it is infinity to infinity. Now what about tan minus x? Tan minus x. Yes. Now the only difference is that it has reversed. Yes. Let's remove this square. Right. See, it has just formed a mirror image. Okay. See, the advantage of being able to visualize these graphs in your mind is that many times it will very clearly tell you whether what you are thinking of a value is correct or not. Okay. Now that is, I think, enough for today. Bye for now.